Hello everyone. Good morning and good afternoon. My name is Nishant and I am from India. And I am working as a professional backend developer, and I am working on technology with Java Spring Boot. And today's my presentation topic is edge computing. Let's go through it. So the my agenda, I will discuss all about this topic in this speech. So once I will introduce you to edge computing, then I will tell you that why edge computing is matters and where then edge computing architecture I will explain you and use cases and application and the challenges and future trend and opportunities. So let's first introduce you with the edge computing. So edge computing refers to the practice of processing data closer to its source rather than in a centralized data center. It reduces latency, improve performance, and enhance privacy and security by processing data locally or at the edge of the network. So what it will do, it will get data from the IoT devices and from there, and it will not directly store to the cloud. It will first do processing all things. So I will explain all these things in this slide. So let's talk about why we need edge computing and why it matters. So when we do directly connect with the cloud computing, so we have some issue with that. So there is a latency issue, and it's reduce the performance there, and it's not a real-time data transfer. So when we that's why we use the edge computing. It's a layer between the IoT devices and our data centers and between the cloud. So so let me explain you the architecture of the edge computing, how it's work. So in the we have three layers. So first one is a device layer, second is edge layer, and third is cloud layer. So in device layer, we have let's take example like we have mobile, computer, cars, and industrial, and so on. So it will produce some data and some inputs, and it will then it will share the data to the edge layer. So what it will do, it's a local network, data process and reduction, data catching and buffering, control response, and virtualization. Means it will process the data, and if that threshold value will cross, then it will send data to the cloud. Otherwise, it will not continuously sending the data to the cloud. Only needed data will be stored in the cloud. And third layer we have cloud layer. So it is big data processing at data warehouse. So here actual we our data will be stored in cloud. So our data, so the sensor and nodes are continuously sensing data and all the things. So we don't want to store all the each and every data to the cloud. So that's why we use edge. So let's talk about some use cases and application. So we can use edge computing to improve patient outcome, to fraud detection in traffic management, in crop monitoring, and in real-time video analysis, and better supply chain management. So talk about fraud detection, how we can use edge computing in fraud detection. So edge computing plays crucial role in fraud detection by enabling real-time analysis of data at the edge of the network, closer to where the data is generated. For instance, consider a scenario where a financial institute processes transaction from million of customers. Instead of sending all transaction data to the centralized server for analysis, which could be introduce delay and increase the risk of fraud. So edge computing allow the institution to analysis transaction data locally at the point of sale or at the customer devices. So this is the one example how we can use edge computing in the fraud detection. So there is so many use cases and where we can use cloud computing. So challenges we are facing if we use edge computing. So it in in the remote or harsh environments such as rural areas, offshore location, or industrial site, network connectivity may be limited or unreachable. This can be pose significant challenge the cloud-based computing model that rely on consistent internet connectivity to access centralized server. So if we use edge computing nodes in the rural area and where the internet connectivity and bandwidth is not good, so that time it will be 10x for data management and security concern, including privacy, compliance, and cyber threats. So in the edge, there are so many edge nodes. There we need to keep all the nodes should be secure, and we have to send this not don't send the private data there. So we have to keep 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 secure all the data, all the node of edge computing. So optimizing energy usage and battery life of edge devices, especially in remote location. So we have so many edge nodes, so we need to continuously give power battery to the devices. So we have to also, this is also one challenge. So complexity of edge infrastructure management, including provision and maintenance. So we have to keep maintain our edge computing nodes every time, and we have to keep think all about they are working or not properly. Yeah. So future trend about edge computing in future where edge computing will be used many times in most of. So we have some example like edge AI we can use in 5G, in Internet of Thing, in edge analysis, in blockchain. In this, all these are the future trend and opportunity where we can use edge computing. So yeah, thank you.